Hello and welcome to this lecture on analytic function. In this video, we are going to solve one more property in the analytic function. So it will be if a real part of analytic function is constant, then we say that f of z is a constant. So we know that f of z will be equal to u of x comma y plus I into v of x comma y. So what they are saying that the real part, this is our real part if it is a constant function. If it is constant, then we can say that the whole function f of z is constant. Okay, so first of all, we want to prove that if the real part is constant, then f of z is constant. First, we take the function f of z. Okay, then if I am assuming that a real part u of x comma y is constant, if I differentiate this function, if I am assuming that u of x comma y is equal to c, if I differentiate this function with respect to x, what will happen? I am getting 0. If I differentiate this with respect to y, if I differentiate u with respect to y, I will get the value 0 because it is simply a constant. If I differentiate this function with respect to any of the variable, surely I will get 0. So already we know that the function f of z is an analytic function. Analytic function, it will satisfy the CR equation. CR equation will be ux equal to vy and uy equal to minus vx. So this can be written as ux equal to 0. Here it is uy equal to 0. So if I am equating ux equal to 0 means we get in this equation, if I am using these both on this equation, surely I will get that vy equal to 0 and vx is equal to 0. So if I am differentiating the function v with respect to x and y, I am getting 0. What it represents? The function v of x comma y is also a constant function. If I assume here it is c1, it will be c2. So with u and v, see, u is a constant. This is our assumption. And if I assume u as a constant, I am getting the result v as a constant function. So if u and v are constant, then definitely f of z will be a constant because it is a sum of both the terms. Any constant, complex number will be a constant, no? So definitely f of z will be a constant. Let me watch the proof. So ux is equal to 0 and uy is also equal to 0, and then we know that ux will be equal to vy and uy will be equal to minus vx, and I am equating this now. Vy will become 0 and vx becomes 0, which implies v of x comma y is a constant. If I assume this as c1, here it is c2. So it replies that v of x comma y is also constant. We know that f of z function can be written in the form of u of x comma y plus I into v of x comma y. So if I am adding both, definitely it must be a constant. Therefore, since both u and v are constant, we can write the function f of z equal to as constant. But it is a complex number because there is a imaginary and real part. So finally, we prove that f of z is a constant function.